All right, well, it's a great pleasure today to host Daniel Wigdor. But before that, my name is Gerardo Benko. I'm a researcher here up at Natural Interaction Research Group. And I've had a pleasure to actually work with Daniel on several occasions in the past. Daniel is a fantastic speaker, so I think we're all here in for a treat. Welcome, Ken. I know it's early. He is currently a professor at University of Toronto. He was also a student at University of Toronto, but he did this in a roundabout way of going out. He has an illustrious research career working for Mitsubishi Research Labs, working for Microsoft. He worked on Surface in a Surface group, as well as had a stint here at Research. We did a bunch of projects together. And in the meantime, he also worked at Harvard, I believe, with Cha Shen on different projects there. So he's been around. Many people here know him, and he always gives some fun talks. He's been really active in the touch and gesture community, but he'll tell you right now that that's so passé, and he doesn't work on that anymore. So now he turned his attention, laser focused, on a new topic for him, which is kind of developing tools and applications for kind of ubiquitous computing scenarios. He calls them Symphony of Things?
Symphony of Devices.
Symphony of Devices. Sorry, I messed it up. One thing that I tried to do correctly, I messed it up. Anyway, so without further ado, I'll give you Daniel.
Thanks, Benko. It's always so fun to come back to 99. Thank you, everyone, for coming out. As Benko mentioned, I'm now a professor at the University of Toronto and co-director of the Dynamic Graphics Project Lab. There are two major projects that my group focuses on. The first is high-performance interactive systems and purging all latency from the world. But our early collaborations were all with MSR, and I didn't want to repeat things that people had seen before, so I'm not going to be talking about that today. Instead, I'm going to be focused on this Symphony of Devices project that Benko told you about a little bit. Now, I should say, as a professor, my job isn't really to run my own research projects directly anymore, right? My job is to go out and find money and to help other people to do exciting and fun research. Really more of a middle manager than it is a research gig. But what it does mean is that I get to work with a lot of really fun students who have done wonderful projects. I'm going to be sharing 4 of them with you here today. Stephanie was a master's student, and she did a field study that I'm going to be telling you about shortly. Peter, who has just moved on to his PhD and is now interning at Yahoo, did some of this work. Anthony, who is right here in the room, was interning at Autodesk, and I had the privilege of collaborating with that team, and I'm going to tell you about that project as part of the larger Symphony project, and of course Jisho as well, who is also my master's student. So the talk is largely comprised of these 4 papers. So if you want to go back and get the source material, that's what it is. So Anthony in his talk had what I think is a really startling contrast that I think is a great way of proving the point that the era of ubiquitous computing is here. So this is the papal conclave for Benedict XVI in 2005. The crowd eagerly awaiting the announcement. And this is Pope Francis in 2013. Notice the contrast. Can anyone really argue that the era of ubiquitous computing, if not having arrived, if we haven't yet achieved the true vision, at least it has begun? So what does that mean? Well, what it means is that we have this huge number of devices. And this too comes from Anthony's talk. This is what my lab looks like. I don't know if everyone's living room looks quite like this. But we're soon to be flooded with devices. Now, many people think of this as an era in which you might have a smartphone, maybe a desktop computer, although that's becoming increasingly unpopular, and maybe also a tablet. But the way I think about this, and I think the way a lot of people in ubiquitous computing have been thinking about this for quite a while, is not to think about these as individual devices, and certainly not to think of them as devices that are owned by an individual, but that eventually we will think of them the same way we think of this, a ream of paper sitting on the shelf. Now, what I love about this photo of this ream of paper is that it's such an unimportant product that they didn't even bother to spell it properly. Right? If you look at the description of the price tag down at the bottom, right? It's recycled or something, not recycled. Right? This is how unimportant paper is. You don't distinguish yourself with paper. Maybe you think, oh, I want to be good for the environment, so I'll buy the recycled stuff, right? But this is how you think about it. It's cheap. If I were to walk into someone's office when I was meeting with them today and there was a stack of paper, I wouldn't even think about taking one and writing with it, right? But right now, I would think twice about grabbing their iPad and taking notes with their iPad. But soon enough, this will be the way we start to think about these ubiquitous computing devices. These technologies will become as cheap and as plentiful as paper. Now, for anyone who studies ubiquitous computing, this is not in and of itself an original thought. But the key that we see to this at the University of Toronto is moving from the giant clutter vision of the world and the disparate large number of devices of the world to what we call a symphony of devices. And the core idea behind the symphony of devices is, rather than just having individual screens that you have content for or developed for, instead, think of the large collection of devices that the person has and target applications for the person and not for their technologies. So this has started to happen in a few places for specific form factors. So this is Microsoft's attack, which is called Smart Glass. Am I getting that name right? Where you can write an application that runs on the phone and it runs on the Xbox. Right? So if you're sitting in the living room and you've got your Xbox running, you can interact with it with your phone. If the person has created an experience, the developer, the people who made the game, created an experience that allows it to span that way. It's not just Microsoft. Samsung also sees this as their future, so they have applications that run on their phones, and as long as you have a Samsung TV, you can control your television from your phone. And there are lots of these sort of targeted tools. What we're trying to achieve with the Symphony, though, is a little bit different. What we're trying to achieve is a way for developers to create applications without having to focus on the form factor and without having to focus on the context of use. Because the problem is, right now you can develop a smart glass application. You say, OK, what's the scenario? Well, there's a television and there's a phone. And maybe there are two phones. And that's sort of a scale that is reasonable to ask them to design their applications for. But if you think about what's going to happen, and what has already begun to happen, is this explosion of different device form factors. Now, this has created a couple of problems, one of which has been talked about for decades, which is writing an application once and having it run everywhere, right? War. What I'm interested in is similar but subtly different from that. I'm interested in enabling development teams to build applications that, yes, can run everywhere. And I think the closest to winning the write once, run everywhere is probably HTML. But you might have a different opinion about different tools. What I'm interested in is similar to that, except I want our experiences to grow and to shrink across all of the user's available devices. So if right now when I'm giving a talk, I have my computer and I have available to me a large screen, the application should spread out and take advantage of those screens. And I'll give you a more specific example in just a second. Now, the role of the cloud in all of this, of course, is to be the connective tissue between all of these devices. But it's important to understand that the approach that's been taken so far doesn't yet allow us to achieve it in a meaningful way. We have experiences like iCloud, and I forget what Apple calls their ability to play video from the phone and it shows up on the television. Does anyone remember what that's called? AirPlay. Yes, AirPlay. Thank you. So this starts to get there, right? And with iTunes, if I buy a song once, and my wife is on the same iTunes account, so if she buys a song, it shows up on my phone, right? And that's certainly starting to get to what all of us as computer scientists have wanted to envision. But what this is about replicating experiences across devices. So if I pick up my phone or I pick up my tablet, I can have roughly the same experience. The video is there, the song is there, the applications are there. SkyDrive, I have to get a new screenshot. The Ministry of Truth has decided this is called something else now, right? OneDrive? OK. I apologize for that, and I should have fixed that slide before coming over. I figured it might change names again this morning, though, but anyway. So SkyDrive is a wonderful tool. I use this a lot. But it, too, is about replicating experiences, right? I was really impressed that when I got my new PC and it backed up, restored from Windows 8, it had all my passwords still. I mean, that's great. But again, it's about replicating experiences across devices. Netflix, same thing. I can watch a movie on my tablet on the bus. You get home, you walk into the living room, and you resume, and it plays from the same place. Amazon, same thing. I'm reading a book on one device. I put it down and pick up another device. It knows what page I was on. Replication, replication, replication. So what is it that we want to achieve? Well, this is a version of the cloud that we're starting to see as a more popular thing where the applications start to live in the cloud and actually get delivered to the devices. Adobe recently went to a subscription model for their software. Microsoft has gone to a subscription model for their software. We have this vision of the application living here and being sent down. Now, we've built that before. A project that I did at Harvard University, as Benko mentioned, looked at how can we enable people to take pixels and control signals and share them across devices. So I'm going to show you that project very quickly. Here's an old video.
Provide the walk-up and use environment for conducting collaborative research. Users bring their laptops to an interactive table and connect to a server with a lightweight client and share their screen images on a high-resolution data wall. Each laptop screen on the table is rendered with a control bar with buttons that allow users to switch the priority of the image. These images are automatically laid out based on the priority of each display. Users are also free to manually manage the layout on both the table and wall surfaces. Gestural input on the table controls the magnification and placement of the laptop images on both the table and the wall. Double tapping on a laptop image enters a full screen mode with mouse simulation. In this mode, the synchronized view between the table and the wall is severed. User actions on the table are interpreted as mouse input and sent to the client laptop. After finishing the mouse commands, this user taps on the toolbar to switch back to the synchronized view.
So that was a tool that allowed astrophysicists, and of course, Paul, you recognize this, right? This is the main room at Merle where we did a lot of this research. This allowed astrophysicists to bring their research projects into a large room and do screen sharing so that their application would show up on the table, and it was actually their laptop, and they could go in and edit their content and would also get mirrored up onto the wall. This is very popular, but this too is different from what we're trying to accomplish. What we want is applications that automatically grow and shrink across all of the available devices. So, finally, a concrete example. Panorama is the tool that I'm going to tell you about at the end of the talk that allowed us to create these applications. But let me show you this app. So, imagine if instead of using PowerPoint to give this talk, I was using this slide presentation tool. Okay? So imagine this is up on the screen and I'm giving the talk this way. You see, of course, the main slide. You see the speaker notes. You see the list of slides that are available to come up next. And if you look carefully, you can see a timer in the bottom right corner that shows how long the talk has been going. Now, in PowerPoint, if I plug in a projector and I hit F5, right, it'll make this full screen. And there are people who have written special applications where if I connect my phone into this, I can advance the slide. Okay? But what if I want something a little bit different? What I want is, if I plug into the screen, I get this experience, but I want to be able to give a more dynamic talk. I don't want to have to be glued to the podium. So what I want to have happen is, I connect my phone into this Symphony, and what it will do is, it recognizes that the phone is a small, private screen with a good touch screen, so he's connecting in. And this application doesn't know anything about the phone except for those physical properties. And you see the notes, the slides, and the timer have all transitioned down to the phone. And the current slide stayed on the big screen. Now, this was not custom written for this phone. It was not, the developer of this application didn't know that there would even be a phone involved. What they knew was that they wanted to be able to have their application always keep the current slide on the biggest screen that was public and move the list of slides, the notes, and the timer to something that was more private. Okay? So let's say you want to give a slightly more dynamic presentation. All right, I've shown you that. And let's say you want now to be able to walk around. Well, you can connect your Pebble into the system, and it gets recognized as a device that has time. So in a moment, it'll pull the timer down onto the Pebble so you can see how long your talk has been. So instead of seeing a clock, you'll see contextual information. It also recognizes the presence of buttons. And so the user is going to be able to push buttons on the side of the device, and it'll transition the slide from one to the next. Okay? And here again, the developer didn't know about Pebble. The developer didn't know that there would even be a watch connected. What they knew was they wanted the timer to be on something that could be very close to the user, and they needed to be able to push buttons to advance the slides, and it recognized that that too was close. There's a problem with this, though. If I'm walking around with a Pebble on the stage, and I'm giving my talk, I've lost my speaker notes. Right? I can't see them anymore, so I end up going back over here. And you don't really want speaker notes on this little screen, right? So you don't want to be going like this the whole time you're talking. So what do we do for that? Well, we connect in a Google Glass, and the system recognizes that this screen on the side of the Google Glass is small and private, and so the speaker notes automatically move over to the Google Glass. And so now a speaker gets a personal teleprompter right there in front of them. And yes, I see Paul sort of making this sort of head gesture while you're giving your talk. So you too can look like a zombie while you're giving your talk, right? The next version of Google Glass, they put it a little bit lower and it's a little less apparent. Anyway, so this is the tool that we're trying to achieve, this automatic reallocation. And it doesn't stop at one user. So if someone is connected with a different account into this presentation, what they see on their tablet, which is different from the speakers, is the list of the slide that's currently being displayed. Right? So you can follow along with the slides with it in your lap, maybe take some notes. And in addition, they can hit a button that shows them additional information about a slide. So if someone just shows you a bar graph, but you want the underlying data, you can see the publicly accessible content of the presentation. Let's think of this as like a public version of the notes for each slide. This is a feature that doesn't exist in PowerPoint yet. But if you added it to the application and you said, this is public, but I want it to be on a private screen, on a small display, it would put it here automatically. So this is what we're trying to get to. And this application has been built. We've built the toolkit. Let me show you what we're going to build into it and why. So to achieve our Symphony of Devices, we underwent 3 steps to the work. The first was to understand how do people currently use many devices? What are people doing in the world? Are there people who use tablets and other devices in parallel? We then look at interaction design. So what are the things people want to do with these devices? How can we achieve the great functionality? And then finally, we built developer tools. So I know this is the show me building, so I'll go quickly through the ethnographic stuff. Mary's not here, right? No, OK. All right, so what did we do? We went out into the world and we found people who had distributed workspaces. We did this through advertising on Facebook and Craigslist, and we said, we want professionals who have what we refer to as distributed workspaces. And the way we defined this in the call was, you had to own a few devices. You had to use them in different places. So you did work from home, you did work from the office, et cetera. What did we get back from our call? Well, we got a whole bunch of people. These are just 9 of them. But a large variety of professions. These aren't just undergraduate students in computer science between the ages of 17 and 19. We have design consultants, architects, managers, physicians, et cetera. In fact, the population of the study is distributed across creative endeavors, some engineering, healthcare, business and marketing, et cetera. So what did we see when we went out to these people? We met with them in their workplace. We interviewed them to understand what it was they were doing. We saw workplaces like this. So this is one person's desk, and this is far from atypical. Jonathan will certainly appreciate the use of multi-monitors here on the table. But in addition, of course, to the multiple monitors, we have the laptop that's over here on the side. And when this person is at their office, they plug the laptop in, and it's driving all 3 of those monitors. They also have front and center an iPad, right where you would expect the keyboard to be. So what is the role that the iPad plays? Because a lot of people have this vision that the iPad is the thing you use when you leave your office, right? I know Ken and I have had many conversations about people actually use the iPad at the same time. So how is that happening? And then, of course, just as interesting to all of us, I think, is the presence of all of this paper for hand notes and real artifacts, right? We haven't reached the paperless office yet. Is no surprise to anyone. Additional workplaces. This is a developer who does engineering work. We see a couple of keyboards and input devices. We see a bunch of screens, et cetera. And here, too, again, we see a tablet sitting off to the side that they use simultaneously with their work. Okay? Same thing again. This is an architect's workplace. We see an iPad and a phone sitting and facing her while she's doing her architectural work. And then this one I threw in just for Ken. we see a laptop and, of course, a pen tablet off to the side here so that they can give different forms of input. Right? So what is all of this? What do we do with all this information? We did a couple of things. We built what we called the artifact analysis matrix, and I promise I won't take you through all 10,000 or so cells of this thing. But essentially what it was that for every piece of technology, and by technology I include things like paper notebooks and cameras, we analyze what role does that play in their work, how does it get used, and how does the information flow from that device to another device. Okay? This is more or less a classic technique of artifact analysis. Now, whoops. Come on, presenter view, where have you put me? I love presenter view 99% of the time. There we go. Okay. And we understood what is their multi-device workflow, how do they use all of these technologies, and then especially focused on what are the things they want to do that they can't. So what did we find? Well, Stephanie developed these landscape diagrams, which are actually an incredibly useful tool. This is one person's technology and their workflow for one of their tasks. So we see things like the collaborator and their client sending information via corporate email into their Windows laptop. From the Windows laptop, they use techniques like getting information into Evernote so that it can then go to their Android phone, because there isn't a good way to get directly from the Windows computer into the Android phone. I'll take you through a couple of these in a little bit more detail, but understand the arrows are flows of information, and the little pictures are people or artifacts, and then we have services, cloud services, and applications. Okay? We've got a couple of dozen of these for each of the participants. Now, there are a couple of sort of obvious things that emerge from this tool. Why does it keep jumping around on me? I'll try the touch screen, more touch friendly. Here's one. Does anyone notice anything interesting about this graph? What do you say? Split in half, right? Yes, completely split in half. We have professional and personal. What do you see? What are the technologies you see when it's split in half? There's always one of these. Right? If you've got a BlackBerry, and other people have noticed this in the industry, if work makes you use a BlackBerry, you generally erect a firewall, and then you have all your Mac stuff at home, right? And Windows laptop, of course, too. So we're able to use this to understand things like what are people's workflows, but then also what are the patterns that people follow when they're trying to use all of these technologies to do their work. So I'll take you through a few. We have different information flow patterns. We have the findings about the specializations of the devices. And we have findings on data fragmentation. And again, I'll get to the cool stuff, to the toys quickly for this crowd. But let me give you a little bit of intuition of why we care about this. So first, when we talk about serial and parallel patterns, what we find when we say this is, how are people using these technologies one after the other? Or how are they using them simultaneously? So an example of a serial pattern is what we call the producer-consumer. And this is sort of the classic vision for how tablets get used, right? You use your laptop to write a document in the first place, and then you send it over to your tablet. And almost invariably, this is done by emailing it to yourself or by sending it through a cloud tool like SkyDrive or Dropbox. Okay? So the producer-consumer pattern we found over and over and over again, that people would use these devices with better input technologies, and then they would put it away so they could sit more comfortably and use their mobile device, or they'd do it that way so they could use it on the bus, or they'd do it that way so that they could take it to show someone else. Okay? Also interesting to us was the frequency of the performer-informer pattern. So what that means is we have the primary device, like the laptop, but simultaneously they would use a second device, usually a tablet, but sometimes a phone, to look up information. So and I imagine now that I'm showing this to you, you'll realize you do this too, right? You'll be maybe writing your program on one thing and then looking up APIs on your tablet. Now this, although we all sort of realize that we do this if you have a tablet, you stop and you realize this is actually a pretty painful way to work in some ways, right? One, the input device sucks for this other device, but fine. They like having the portability. They like having this dedicated screen that they can use in parallel. But the other thing is, if you were looking up API documentation here and then wanting to follow it in the program that you're writing over here, what's the problem? Copy and paste, right? There's no clipboard between these devices. And these are the sorts of really obvious findings that come out of this once you see the technique. So we see things like, when we ask people, why is it you use all of these devices? Why don't you just have the documentation open in another window on your laptop? Or why don't you just have a second monitor and put the information over there, right? But what we got over and over again are people who say things like this. There is something about the geometry of one's desk. You can have some notes sitting literally on the meat space as opposed to the computer desktop. Even with 3 screens, it's handy, right? They like the physicality. They like being able to have that API. And these are only some of them are engineers, but I'm going to keep putting it in engineering terms. They like having that API documentation, right, where they can reach and grab it, right? Alt-tab isn't fast enough for these people, okay? All right, so what else? Things like performer-informer-helper is another design pattern. So this is similar to performer-informer, except we add this helper device. I got to stop using the mouse to click in presenter view. It jumps to a different slide. Are there any office people in the room? I'm going to put the mouse over here. Someone yell at me if I reach for it, okay? Anyway, performer, informer, helper. The only difference with this is they add yet another device to do things like they'll have a calculator up on their phone, right? And they'll have this designated tool they can always go to and find a calculator running on their phone. And you think, why don't they just run the calculator app in Windows? But people like the physicality of this other device, despite the fact that it has the copy and paste problems. All right. I'll let you read the paper for a much more detailed analysis of all of these design patterns. I think it's really interesting, but I know we want to get to the toys. Certainly, we found a lot of specialization of the devices, where, just as we would expect, if you have a desktop computer that gets used to do things like composing information, composing content. If you have a smartphone that's used for things like collecting data out in the field, it might be taking pictures of a site and bringing them into the computer, et cetera. Tablets get used for reading and having an extra display. Exactly the sorts of specialization that we expect from all of this, but the surprising finding that we found was people much more quickly go to their specialized devices. Right? Even when they're sitting at their desk, often people will pull out their phone and run the calculator app on their phone instead of running the one in Windows, even though there's no copy and paste. Okay, so they end up retyping things and having transcription errors because they like the physicality. Last. Oh, good. So it's happening on the touchscreen now, too. So at least it's consistent. OK. Data fragmentation. So this comes as no surprise to anyone, I think. Getting information from one device to another sucks. What is the fastest ad hocing network technique that people use for information sharing? Who thinks it's Dropbox? Everyone said it. Who thinks it's email? Yes. We all do that, right? You'll email things to yourself just to get it onto your Windows tablet, okay? So we have this sort of a workflow. You save your content, you open the email app, navigate to the file, attach it, pick your device, all the way back through. Okay? And of course, what this does is it moves it off of a shared file system. So now you have this extra version of the file hanging out in your email. And you save it there, it doesn't save back properly. And I should say, I am completely in love with the new Office for iPad because of its OneDrive integration. It's awesome because it solves many of these problems. All right. What else do people want? Over and over and over again, we see people trying to perform tasks together on devices. I mentioned the calculator model. Someone's using a calculator on their phone. I mentioned reading documentation from one device. People want this. I want it. You want it. We want to be able to have all of our devices share information well. But it isn't just about running an application on one device and moving it over to another app. It's also about being able to take the information and divide it up, or the application itself, and divide it up and have specialization. So if you have an application that has all of this functionality, we don't just want to have it running on one screen and then have this other thing hanging out on another screen. We want to actually be able to divide it up and use one application broken up across whatever devices I have available to me at a given time. And critically, to be able to understand if that device is good for something, if it's good for data entry, if it's good for having a big screen, if it's good for having a good touch input, that the content that gets put there, the portion of the application, is appropriate for that device. Okay? All right. Let's talk about technology. I'll take questions on the way through. Does anyone have a question about the ethnography? No, we want the toys, right? Yes. Oh.
Did you also explore the idea of public spaces and use of devices in public spaces? I saw some examples of office space as well as domestic or house settings.
Yes.
But did you also look into public spaces like museums or other places?
Yes. So the question was about public spaces. Did we look at how people use devices in public? Some of our users work exclusively in public spaces. So their notion of their distributed workspace is that they go to a coffee shop every morning and camp out. Okay? So there were lots of examples of people using private devices in public spaces. In terms of public devices, like being able to use a large screen that you can walk up to at the airport or something, I don't think there were any examples of that. Maybe it's just that Toronto isn't high-tech enough to have large public displays that we can share information on yet. Although I keep wanting to be able to send info to the CN Tower, because it's got this light display that I want to be able to send things to. Yes?
Okay, before we move on, is the ethnographic, is that written up in Stephanie's thesis, or where is...
It's a UbiComp paper, 2013.
Okay, that's the most complete.
Her thesis is more complete. I'm happy to share it with you if you want to see it.
And then the other thing, which maybe we can take offline so you can get onto the show me stuff, but one key question here is, you're saying that people prefer to have the stuff on their devices, and that is a possibility. Now, the other possibility is that the way it's so hard to arrange things and access them conveniently on larger devices that you, and I think that's a critical thing to sort out. So it may actually be that they really prefer it physically away, or
right.
it may just be hard to, that just may be the easiest way to access it and reliably. And that, do you have a feeling for that?
Yeah, I mean, certainly I agree with you that if eventually it won't just be like you have one desktop monitor, right, and then you've got this space down here, and in order to get, so the question is, do they really want to have it on a device, or is it that they want to have it on the desk? And if it were one operating system that stretched across all of that, would they be happy just to sort of send the window down to the desk? Or is it that they like the physicality of this other device? Am I getting that right?
Well, or, I mean, then the third possibility is that they'd actually, it would be faster if it was all up in one place where they could move around, but they might actually prefer to just have it in a separate place. So I think there's three possibilities there.
Yeah.
I mean, I agree with you that the second is preferable to what we have now, and that's where you're headed, but there's still...
To be clear, it's definitely faster, right? So if you want to use a calculator, it's way faster to hit the start button, type CALC, enter, and then type, versus pulling out your phone, right, turning it on, entering your unlock code, scrolling to the application, tap, right? It's definitely faster to have it on the desktop.
That's also about measuring how it damages your primary task, right? Because like, if I bring up some document on top of the thing I'm working on, maybe it's faster to do it there, but then I have to go find the window.
Well, that's what I'm getting at.
Yeah. So we have a study that starts to scratch the surface of that I'm going to sneak in the middle of the toy presentation. So let's talk about, let me show you that, and then I think that'll set context for some of this conversation. Yeah.
Yeah. So maybe I'm just one of the old guys in the room. But I find
well, you are, to be clear, but.
Thanks for pointing that out. But I find that I will often pull out the calculator from my phone because I forget that you can just hit Windows and type calc.
Right.
It's not a question of I prefer it on my phone. I actually don't. But it's just this remembering all these different. So it's just easier to remember. Oh yeah, I have this on my phone, right? So it's not because I prefer it.
Yes.
It's just because it's in my mental model that was just easier.
It's definitely in the mental model that it's easier. And a lot of what people said to us, and this will really come out in the study I'm going to show you sort of halfway through what's coming next, is that having a physical token that is that object is very helpful to people, and when people have that option, they like it. So for example, if what we found with our participants was, sticking with the calculator example, it's not that they want it on their phone. They want a calculator, like a real physical calculator that is on their desk and they can use it. And it's not about it's faster to use. It's about they remember that it's there, and they have the physicality of that as their, just sort of have this token. Okay?
Okay, but what if you had a whole wall display and you had your calculator up in one corner and it was always there and nothing went over it and it didn't go over anything? Would that be good enough, or would you really still rather have the physical device up closer? I don't know, but I mean...
It's an excellent question. It's one that has to be answered. I don't know the answer yet either. Right? If window managers were as painless as physical arrangement, right? Eventually the degenerate case is really what it comes down to is, do you prefer pixels or physicality? And I think on that particular question, there's a divide, right? A lot of people really prefer physicality, and it does help you to perform the task really well, but, you know, I don't know yet.
Also, part of it is that's anchored to your hand, because like, no matter where I hold my hand, I know where to look at to see that, right? If it's on some big wall display, even if it stays fixed, I need to remember where to look.
Yeah. Well, I think let's all talk at lunch and we'll figure out the answer to this question. All right. So let's get into the toys that got built. So Peter has this idea. Peter is my master's. He's now a PhD student. His idea is to target, I talked about watches and heads-up displays and wearables. His vision is this. His vision is, when you're working with technology, you'll have a whole bunch of tablets that you can be able to use simultaneously. Are they tablets? Maybe, maybe not. But they are physical devices that you can dedicate Windows to. And the way to think about this work, starting off, is think about these as individual windows of information, right? Instead of having a window manager, you have these tablets. These are all running Android. And he's developed tools to start to solve this problem of how do you flow information from one device to another. And to be very clear, neither he nor I is ideological about whether or not there's a very large monitor in front of all of this. But given that people are excited to use all of these devices and to have the physical token, I think, then we started to solve this problem with this system that he calls Conductor. So to build Conductor, he focused on creating 6 applications. And by using these applications on individual devices and trying to solve the problem of how to flow information between devices, he was able to build his Conductor. So what does it look like? This is the application that I'm going to be using throughout the example. He built this for Kai, which was just in Toronto. So the example we have is a tourist's guide to Toronto. So you can imagine the single device version of this application where you have a list of different things that are very important to see. Of course, the building where my office is the most important. Where our lab is important. And if you see something you like, you can tap it and then you'll see it, right? You can imagine what the smartphone application looks like. Now, he built it for a multi-device environment. So sure, you can bring up information about the CN Tower. But when he adds a second device, like this, now he wants to enable people to have in their hand, as Ken put it very well, to have it dedicated to their hand. Here's the list of things that I want to be able to see, the tourist applications, but I want to be able to send content from the phone over onto the screen so that I can see information about the tourist site on that screen. And by solving this for a tourist application and for a few other applications, he has a generalizable solution. So the question is, how does he do it? So again, as we've gone through now together a couple of times, right now what you might do is you'd try to email yourself a link into the app and you bring up the app on the tablet and you'd load it up. He developed this idea of targeted transmissions. So what does that look like? Well, from the phone, from the first device, he can perform a gesture on any item. And from this pie menu, see a list of all the other devices in the space. And it has the name of the device, just Nexus 7, because all the tablets he had were Nexus 7. But they're also color-coded in a couple of ways. There's a bar at the top. You can see this is the orange device. And then he also colored them orange, so it had a physical bumper. So what does that look like? Well, so here is an arrangement of many devices. He's got his application on the left side, and he's going to send information from one to a different device. And you can see as he goes through the list, we get this little shutter on the other device that says, this is the one you're pointing at right now. So if you let go of your thumb right now, that's where you're going to send the information from one device to the other. Okay? So think of this as being sort of like copy and paste. But it's not quite copy and paste because it's sort of a forced copy and paste, right? As soon as you copy and then you select paste, it changes the application that's running on the other device. So it's a little over the top, but we have additional fidelity. So the question that I put to him was, this doesn't seem physical enough. What we found was people really like to be able to lay out their devices on the desk in particular places, and they wanted to be able to have that physicality mean something. There's great work out of Calgary and other places that look at proxemics. So you can do things like, if you're holding a phone, you can reach it towards another device and share information or affect that device. But we wanted this to work outside of a Vicon instrumented lab. So how do we achieve having the physicality matter? If you've got these two tablets, you want to be able to send information from here to here without having to sort of go through a list and target it, right? So what he does is an approach called broadcasting. Now what broadcasting does is, when he selects to broadcast, it sends it to all of the devices in the Symphony simultaneously. Now the key realization here was, this is a single user application, or a single user thing that he was trying to solve for multiple devices. If you're trying to send information from device A to device B, if you look at device B, it doesn't matter that the information is arriving on your 14 other devices on the table. It only matters if it shows up at the one you're looking at.
Except if you've got context windows.
Let me show you how it works. Okay? So he picks an item and he chooses to have it broadcast. Fine. What does that look like? When he broadcasts it, it shows up as what he calls a queue over here on the side of the screen. Now, instead of forcing the device to go to a different mode or whatever, it just shows up as this little icon on the left side. You can just ignore it. It'll go away after a few seconds. The key features here are, though, we get the color that shows where it came from. We get an icon that represents the application that it came from. And we get a label that says what it is that this thing does. Now, when you get the queue, you can just tap it and say, I want the default action. Right? So if I send the CN Tower information, I tap it to load up a full screen about the CN Tower on the tablet. Okay? You can also choose to do what are called contextual actions. Let me take you through these. So he taps it and it gets the default action. So here it's going to load the CN Tower information. Fine. Okay. Now, what you'll see here second, there we go. You can bring out old queues from the side of the screen, so if they've timed out, you can just get them back again. They live in a little tray on the side. And more queues can show up. You can just keep ignoring them. And again, you can tap it to get the default action. But just as interesting is what we call contextual actions. This is sort of the paste version of this thing. So you've got your queue. And instead of tapping it, you drag and drop it. And when you do that, it pastes it into the current application. Right? So a minute ago, if you just tapped that, it would have loaded the tourist information application and brought up the page. Here, he dragged and dropped it into a web browser. So what does it do? Well, it finds the URL of the thing that he dropped, and it goes to that website. If he had targeted it towards a text field, it would have pasted it like text. Okay? Now, what Peter is going to show here is how to quickly get information from one device to another. So on the very left, we have a contact list. This is a list of people in his contact book. Next, he's going to move from that into an email application, and he'll move from that into a map, which shows, right now, he's just in a map app. But if he brings the queue into the map app, and he's asked for the contextual action, it'll show you where the person lives. Okay? So let's watch him do that. So he chooses the individual, he broadcasts it, that goes out to all devices. He taps it so it loads the default action. He then broadcasts out the contact information again. And when he drags and drops it onto the map, it performs the contextual action of loading it into the map application. Okay, so very quickly moving information from one device to another and always having the right context. You can either preserve the context of what was running on that device before, or you can choose and say, I want to switch applications. Okay? Now, this doesn't quite get all of the multi-device scenarios we want. This requires that you continuously send these requests to affect another device. And they have to get accepted over and over and over again. So what we've created here is the ability to temporarily form a link between two devices. We call this link a duet. Okay? And a duet is these two devices are going to temporarily play together. Now the way that we create this connection is, so for example, let's say I've got a list of videos here, and I want it to be that every time I tap one of the videos, it loads it onto this tablet. Right? Or if it's not a tablet, imagine it's your living room television. Right? And you want to be able to watch a movie when you tap it. So that's done by one of these functionally bonded duets. So here's how it works. We have on the left our tourist application. We have on the right the information about the CN Tower. Recall, if I wanted to see a different one, I'd have to broadcast it, come over here and accept it over and over and over again. Instead, we're going to form our duet. So here's how. He broadcasts a queue. And then instead of putting it in the usual place, he's going to put it over into this link. And that says, I want to create a connection between these two devices. So now anytime he taps one of the list items on the phone, it automatically brings it up on the tablet. Okay? No need to over and over and over again set the same thing. Now, duets are great, but how do you manage them all? And by manage, I mean there are a couple of things. One is, there's going to be an action that this will cause to perform. If I tap CN Tower in one list, it makes sense it would bring up the information about the CN Tower on another device. But what if instead I wanted to do something else? Can't you form other types of connections? So in the developer framework, the developer of the application can choose what type of duet they want to create. So for example, here we've got two map views. And he's going to form two different types of duets. First, he's going to create one that just synchronizes the view. Okay? Then he'll change it and say, I don't want to synchronize this view anymore. I want to see what the other one is looking like, a world in miniature. Okay? I want to have information about the viewport of the other screen. So let's watch that happen. So he brings it over, forms the duet. So now anytime he scrolls one map, the other catches up, complete with latency to make it authentic. And then he's going to grab the duet and put it into the other socket, which says I want to create the other type. Okay? And the user gets a little information that describes the duet that will be formed. So now when he zooms in, it doesn't zoom the map. It just shows what is the viewport of the other map. Okay? So pick your favorite application and think about what are the ways you might want screens to get synced. If there's only one way, that would just be the default duet. If there's more than one, then you can create them.
I have a quick question.
Yes?
To me, the duet looks more like you have a master device and you have a slave device, and you can control your slave device from your master. Is there a way to flip the...
It goes both ways. So if you have the screen synced, for example, and you grab it and move it here, it'll send it to the other device as well. Okay, so it's bidirectional. And the developer can also choose to make it unidirectional if you want to. But that's a very good point. We really want to get away from this idea of master and slave, because I think it's holding back a lot of multi-device computing. A lot of companies are thinking about it as the phone is the master, the TV is the slave. Or the phone is the master, the watch is the slave. Or the phone is the master and the heads-up display is the slave. But it's always about having a master device. We're trying to break away from that completely. Right? This is a democracy in our Symphony. Okay? All right. We have here cross-application duets. So this is a map application running in parallel with the tourist application. So now whenever he taps one of the tourist sites, he sees the current location on the map. Right? And that happens because the duet defines this as a geographical point, and the map knows how to receive it, and so it does it automatically. There's a nice property that this brought out, which was the ability to share peripheral devices easily. We found this to be really painful. We had 20 tablets, and we wanted to be able to pair a keyboard with any of them, right? Bluetooth keyboard. You have no idea how long it takes to pair a Bluetooth keyboard until you try to do it 20 times in a row. Here's how you can handle a Bluetooth connection in Symphony. This, in terms of the Bluetooth pairing, this one is paired with one of the devices in the Symphony. We don't even know which one anymore, okay? When you type, you get a cue that shows up. And if you bond the cue with the device, it sends the keyboard over there, if you form a duet with the keyboard. And now what you'll see is he'll break that duet by throwing it in the trash, and now it goes back to be on the previous device. Okay? God, so much better than the... I watched him doing it. All right. Last bit of functionality, being able to manage all of these devices. So there is a delicate balance, I argue, and we're going to talk a lot more about it, that the physicality of the device matters. And what we found in a study I'm going to tell you about in just a second is that over and over and over again, people would dedicate particular physical devices to particular tasks. This is my email. This is the map. And they would put it in a particular physical place on their desk. Now, the corollary to that is, or the counterpoint to that is, this is all just digital information. So shouldn't I be able to, on the device that is currently my list of emails, shouldn't I instead be able to grab the screen from something else? Now, we provided that functionality, but interestingly, it would get used a little bit, but not very often, because they like this direct physicality. So what you see here is if you hit the home button, your home view is all of the devices that are running, right? Not just your home view on your particular phone. And you can clone a view by just tapping it and zooming in. So then he got a copy of what was on the green tablet. And you're also able to grab a view and move it. So if you want to have the session from the green device on the orange device, you just zoom out to your task manager and drag and drop it. And then the orange device becomes the green device. Okay? So it completely gets rid of this idea of an application running on a device. It just is running in your cloud of applications. You can just zoom in. Yeah.
I always imagine that hoping that I can, like I have a tablet, but to pull up the virtual keyboard is so difficult to type, and you only see a slide of your website.
Yeah.
And can I do like typing in my phone and just transfer them?
Yeah, if you form a text entry duet between your phone and your tablet, your phone can be a keyboard for the tablet the same way. Okay, so I share your opinion that that's painful. Okay, now the study is not just about proving out the functionality. The study is about looking at how do people really use this thing. So what we did was, this replicates a technique that was used for very large screens at KAIB previously. We used the VAST 2006 contest. This is from North and his research group that did this originally for very large screens. And we said, let's have people try to solve this task. So what it was the following. You are a CIA analyst, and you have 230 odd newspaper entries. It's mostly stuff that's in the press. Okay? You have a map, so you know where this fictitious town is in California. At least I think Alderwood is fictitious, but it's set in California. And your job is to find the 10 articles that really do describe this funny business that's going on in the town. Okay? And you're trying to solve a crime. And this apparently is a task. This is something that CIA analysts have to do a lot. So what we gave people was access to all 230 documents in a list. They could, if they wanted to, they could just pick up one device and just go through the documents one at a time, read them. They had the ability to take notes, etc. Okay? I don't know why PresenterView just does not like me.
CIA is not supposed to be investigating crime.
I apologize. You're right. Domestic crime is FBI, yes. I don't know. In Canada, we don't have any of this stuff. Oh, that makes me nervous. They don't like me. Anyway. All right. So 8 participants came in and did this task. Most of them were computer science graduate students. Just to send myself up the way I did others earlier. We gave them a whiteboard. We gave them a paper and pen. So if they just wanted to take handwritten notes, they could. We gave them 5 Nexus 10s, which is a 10-inch tablet, 5 Nexus 7s, 1 Bluetooth keyboard, and it was running our system. And what we wanted to know was, well, first, would they use all of these devices? Would they actually make use of having multiple devices? Now, every user started off the same way. Every participant, I mean to say, started off the same way. They had this stack. All of them were running the application that let them see the content, but they could also switch to a note-taking application, the basic apps that are in Android. And some of them would start off just reading through the list of documents. But very, very quickly, all 8 participants started having a desk that looked like this. And what they would do is they would scroll through and find a document that they thought was interesting, and then they would physically put that document aside. They'd say, OK, I want to save this one and put it over here. Now, they could have used like a flagging feature in the application. It would put like a little check mark on the document so they could go back to it, just like in your email. Didn't use that. Instead, they would use this physical piling to say, this is one I want to remember. Okay? So they use them. How do they use it? Well, I mentioned that physical piling behavior before. And we see over and over and over again the participants using spatial memory to keep track of these documents, like they were physical documents. Okay? So what we found in post-interviews, and I'm going to let you go to the paper if you want to see all the details of the user study, but the point is, most of the participants used all 10 tablets and said they wished they'd had more. Almost no one took handwritten notes, although that may be a function of the fact that they were computer scientists. And people did over and over again do this physical piling. So if we asked them questions about a document, they would know where it was on the desk. They didn't even have to open their eyes, right? They wouldn't have to look at it. They'd say, oh, that's over here. Okay? Yeah?
Did you have a comparison group in which they were using a single screen or multiple screen desktop to do the same task? Because I have seen the same task in one of the information visualization courses that I've attended in a university. And it was the same task, exactly the same task with so many documents, and we had a tool which analyzed things for us and allowed us to bookmark it. And it seemed reasonable for us to do it in a desktop that was like 21 inches big and didn't need as many tablets.
Yeah.
So I feel that this study is sort of like looks biased towards having multiple devices in front of you, and that's why you're using, and you want more, obviously, because every screen has a small screen.
Because it's small.
Yeah.
Yeah. So we didn't, but you're right in saying that we replicated the experiment. So North and his students who did this experiment originally for very large screens gave people a desktop computer and a wall-sized display and looked at the differences in behavior. And we sort of latched onto that as doing another condition. So if you want to see what the baseline was, what North and his, I wish I could remember the name of the student who was the first author, but Chris North is at Virginia Tech. Their findings were, you can do the task on a single device, right? And if forced to, you can do a single task on an individual tablet. But what they found was that however much space you gave people, they would expand out to use it. So what was interesting to us about the tablets was, we give them more pixels, they want to use more pixels. That's sort of interesting, but I think to be expected. What we were really pleased by was how they physically arranged things. Right? The fact that they didn't just use more pixels. They could have just put everything in a giant grid and created a large screen and used it like a big monitor. Right? But instead, they did this physical piling behavior and physical arranging behavior where the physical position of the device was interesting. Okay?
I wonder, I have a follow-up question. I wonder if in your initial study, the field study, which had with 22 participants, you found a task which was common enough that you could have replicated that task with these multiple screens and your application helping them arrange the screen such that the task would have become easier than what they were actually doing. Like we started with the premise that the mental model there was wrong. They were using a device for calculator, a dedicated device for calculator, and a device for something else, although all that functionality existed in their main desktop and that could have been easily accessed.
Sure.
Now I wonder if taking one of those tasks, you could have replicated it with this multiple screen scenario and could have made that easier somehow, and then could have commented saying that our application made it easier for them to communicate between the devices and solve that problem.
Sure. We could have done that, but it's trivially obvious that this makes it easier to communicate information between devices, right? Like just by giving people a clipboard, you make it easier. I don't need to run a lab study to do that. But there are all sorts of lab studies that could be run next, right? And I'm happy to talk to you about it after the talk. Okay. All right, Anthony, I'm sorry, I'm going to have to skip your talk. What this means is you guys are going to have to ask Anthony to present his best paper and best talk winning presentation from Kai at some point this summer. Okay. So the last thing I want to talk to you about is how do you actually build these applications? So if you're a developer, I've talked about this vision of being able to write once and run anywhere on all the available devices. And, you know, this guy promised that a long time ago. Java accomplished it to a certain degree, but we talk about this problem. If you want to develop an application for Android versus the iOS, what is the first problem that you think confronts you and you see complained about over and over and over again in creating Android applications? It's one word, starts with F, but it's not 4 letters. Fragmentation. Right? You hear this all the time. And what does fragmentation mean? You sit down with a developer and you say, well, what is it? You know, yeah, Android is fragmented. What does that mean? Well, it means sometimes the phone has a 4.3-inch screen and sometimes it has a 4.6-inch screen. You think that's fragmentation? You want to see fragmentation? Try making it run on a watch, glasses, and a phone, or a tablet, and writing it once. Right? That's the problem we're trying to solve, is fragmentation of the number of devices. So how do we do it? Well, we built something that we call Panorama. And what Panorama allows you to do is to write an application once and run it on all of the available devices simultaneously. Okay? There's a great video that goes through all of the technical details. I'm going to give you the 2-minute version now so we don't go much over time. But understand that what is intended to do is you write the application, and then every time a new device is connected or a device disconnects, it scans the devices that are connected to this Symphony, and it allocates the UI appropriately. So what does the developer have to do in order to accomplish this? 3 things, and then we do the 4th. They define the building blocks of the UI, which we call the panels. Then they define the attributes of the panels and the attributes of the devices they want them to target towards, and then it gets optimized. So let me quickly show you that. Here's an example application. Everyone's seen this one before. So there is work that's called distributed user interfaces that has looked at this problem before of how do you write an application that will span devices. What the focus of Panorama is in minimizing the pain of the developer experience. So that if you can write a normal HTML5 application, then you can write a Panorama application with very minimal modification. Okay? So here is an existing one, and you say, I want to divide this up into panels. So what are the panels? Well, you look at it and you say, well, the playback controls are a bunch of individual UI elements, but clearly they belong on the same device, right? The play and the pause button and the full screen button, all that is going to be together. So you define that as a panel. Next, we would define the video as a panel. Okay? Say it's a separate piece. What are the other panels? Well, this list of related videos. And the nice thing about HTML5, and I imagine many of you know how to write stuff in HTML5, is that this is usually divided up in the DOM already. Okay? So we're not talking about rejiggering your entire application. We're about finding the right branch of the tree. Okay? What are the other components? We've got the comments box and the text that goes in it. What do we then do? We model the attributes. So what does that mean? Well, what it means is you say, this panel cares about physical size. All right, so I want the video to play on whichever is the biggest screen in the Symphony at that moment. Next, these controls, I care about proximity to the user, how ready to hand the device is. For this, I care about having a good keyboard so that I can enter text on in the comments. And here I care about having a good touch input, fine, mouse input, whatever, but the point is that you want to be able to point. And the developer gives a score for all of these attributes. We did a study where we designed or redesigned existing Android applications and determined that there were 7 physical attributes that would matter the most in our designs, but the developer can define more. For any given panel, you give a score to the attribute that panel cares about. Next, the individual devices need to have those attributes modeled. Now, fortunately, there are information services that you can subscribe to. They're pretty expensive as a developer, but if you're writing an application, it costs you about $5,000 a year to subscribe to this database. And it can, from the user agent information and other attributes of the device, tell you not just this is iOS, but it can say this is an iPad mini. And then it has all the physical characteristics. You can subscribe to that database. Okay? So using that database, we get a score for each of these physical attributes. So in this particular Symphony at this moment, there's a 50-inch TV, a Dell laptop, an iPad, and a Nexus phone. Okay? You can see decreasing physical size, how good is the keyboard, how good is the touch, et cetera, et cetera. And then we stick it into a linear optimization. And the linear optimization allocates the different panels to the different device. You always get the right panel on the right thing. Okay? Okay. The panel tag is the last thing I show you. This is the code, some of the code, for a drawing application. We've got the drawing canvas here. This does not have the panel stuff in it yet. There's just normal HTML5. Okay? Drawing canvas up here is inside a div. We've got the buttons that change the color palette, red, green, and blue. Okay? Pretty basic application. So the developer would say, well, I want the canvas to be in one panel, and the controls will be in another panel. How do they do that? Well, they just add some panel tags, and they say, this is the palette panel, that's the canvas panel, and a little bit of class information that ties it back to the panel definition. And the panel definition, which is here, this is new code that they would have to write. All they have to provide, in addition to sort of the obvious things like giving it a type and a name, are these affinity scores that I showed you before. Okay? This is where they would say, I care about big screens, I care about quality of touch input. Okay? Then we get applications.
The global panel state need not be completely synchronized. In this map application, we use the global map panel to synchronize the local viewports of 3 tablets, but not the type of map being displayed, allowing each map panel to provide different information on the same location. Similarly, a Street View application could synchronize the GPS coordinates, but not the viewports, making it possible to achieve a panoramic view of the road. Panorama also allows this PDF reader to display consecutive pages on additional devices. Synchronization ensures that all pages flip simultaneously, while an unsynchronized device can be used to display a helpful diagram or a list of citations. Unsynchronized local panels may access the global panel on demand. In this video player, a user uses the push function to broadcast a local video to the global panel for group viewing. Other users may use the pull function to copy the global panel contents to their local panels for private interactions.
Okay. The paper has a lot more details on the technical implementation. It has a lot more details on a developer study that we ran. It's the first time I've ever had to pay participants $150 an hour to come be part of a study. It was fun getting that by the grant people. Okay. Anyway, so the nice thing about Panorama is that a team has spun it out, and they're actually building this as part of a startup operation led by someone named Robert Levy, who is a toolkit architect from Microsoft previously. And soon will be available at a store near you for free use. I don't know why the store would carry it. It'll be available online for you to use for free. Okay. So that's the Symphony of Devices project. As I've said, all of these are in much more fleshed out in the appropriate papers. And here are all the references. And again, I apologize, Anthony, that I didn't have time to show your work. We had good discussions instead. So thank you for that contribution. Anyway, so thank you very much.
We have time for a few more questions.
So I didn't ask before because I think it might be off topic. I'm very interested in that experiment, and because most of us are raised from like we are trained to use paper, pencil, calculator, so that we kind of have the memory that using it that way. But the new kids maybe born in the new century, they might get used to all these new technology. Is that, what do you think?
Yes.
Like if you replicate the same experiment after 20 years, what do you think the result?
Yeah, so there, there's sort of a nature versus nurture conversation to be had here, right? Of does spatial memory come about from learning, and is the physicality that is associated with it inherently joined with spatial memory, or can you have all of the same sense but entirely virtually? So if a baby is born and you put a VR helmet on them and the way that they point at things is with their eyes and they never use their arms, would they be just as good at being able to find things quickly and, to Ken's point, not interrupt the task that they're doing, right? My intuition, despite the fact that it's the exact opposite thesis of the book that I wrote while I worked here, is that that there really are inherent properties in psychology that we have to tap into. This is not an original idea in HCI, right? We borrow from psych all of the time, and there's a lot of really good work on spatial memory that we draw from. I think the perennial project that I would think of when I think about what is the virtual version of spatial memory is probably Data Mountain, which was something that was done here a long time ago. Not that long ago, 20 years ago, give or take. And it's sort of the virtual version of all of this. So would people be just as happy with a Data Mountain as they would be with all of these physical devices? I don't know the answer to that question, but I think that's worth answering.
Yeah, so following on that, I don't know the answer either.
Yes.
But if, let's say that they developed a new device that would enable you to detect how far it is to other planes that are flying near you. Now, would a pilot rather have that as on their phone, or would they rather have it as another panel on this physical control panel that's one panel that doesn't move? And I think we know that for that one, they would rather have it up there. Now, if the pilot may not control the entertainment system, but if they did, then they might prefer to have the entertainment system controls in their pocket.
Right.
And so I think that, so the point here is that I think it's a pretty complex space, and it's probably not all or none, and it's going to be based on the different tasks involved and the context. And so I think that these are really interesting questions, and I think the Windows management system clearly pushes us in certain directions, and so if we did have a better one, it could change sort of the balance.
Well, I think that's true, and I think one of the works that any student who comes on the Symphony project, they have a stack of papers they have to read, and one of them is your multi-monitor work, right? And one of the conclusions, I'll tell you in case you don't know, is that 2 monitors is not the same as 1 monitor of the same size, right? And yes, it's about the window manager and the way Windows treats that, and when you hit the maximize button, what does it do, right, to the different screens?
15 years ago, we didn't have as many devices, but I did see cases of people that would have the first smartphone or other devices on their desk just showing their calendar, for example. So it's.
But I agree with you. I think it depends on the task, and I think physicality matters in a couple of ways. One is you want to always know where it is, right? And it's you go into someone's office and you say, "Where's this paper?" and find. I actually had to tell my assistant to go cash a check that I'd forgotten to deposit in my office, and she, pouring through papers, and wouldn't have been great if she could have just typed search and hit, where's the check, right, or known it would be in the right place. My favorite example of this now is a feature that apparently Land Rover is actually going to come out with, which is, people drive these giant cars, and the hood is in the way, so you can't see if you're going to run over someone's dog, right? So they have the backup cameras because people don't want to turn their necks, right? And you see the thing down here. But Land Rover's added cameras to the front of the car. And so you think, well, where is that display? They have registered it, and they do it as a heads-up display on the windshield where the hood is. So it looks like you're looking through the hood to the video display of the thing, right? And what I argue there is it's not just about the fact that you always know where it is, right? But the fact that it's in the right place is helpful too, and less disruptive to the task, right? So I think, yes, tons of issues that come to bear on all of this and ripe for plucking at. Oh.
I have a technical question.
Okay.
So, because you use some optimization program to determine which screen, which device you use for certain tasks.
Yes.
Is it running locally on some of the device, or it's on the cloud?
It's running in the cloud. So it's a cloud. So the question was about the linear optimization function, and we base our work on that, by the way, from a fellow who's now at Harvard named Christoph, whose last name I can't pronounce, who did linear optimization for allocating individual elements and figuring out what type of button should be shown or should it be something else. Is it really that simple? Oh, all right, Gaius. There we go. So Christoph Gaius. Anyway, so his anyway, backing up. Is it in the cloud? Yes, it's a cloud service. And then that begs the question, well, what if you're traveling to the US and you live in Canada, you don't have SIM cards in all your devices? Does this just stop working? mean, that's why I gave the talk as videos instead of having tablets and actually showing you panorama dividing up my actual slide presentation, right? So taking a dependency on the cloud creates user problems that some of us sort of forget, which has become very apparent to me with my SkyDrive setup when I don't have internet access on my tablet while I'm in the States, or on my laptop, actually. Anyway, so it's in the cloud. We need to fix that, too.
Yeah, so I think an instructive example, kind of along these lines, is what's happened to electronic test equipment. And it's probably not an area that you follow, but in my youth, we had all these analog scopes and signal generators and network analyzers and stuff like that. And they were each separate pieces of equipment with an insane number of knobs and dials, right, for setting everything. And sometime around maybe the 90s or so, all this stuff got converted into digital form, right? And so when the first digital instruments came out, they basically looked like PCs, right? They had screens with keyboards and people hated them, right? And it was a total failure in the market. And so people went back to basically embedding a PC, in these things, and then connecting up knobs and dials and switches and stuff, so it would look like the old instrument. Now at the same time, you started to see this market for virtual instruments, right? Where you could buy modules that you would stick in your PC that were, the entire scope minus, the screen and the keyboard and, the interface, right? And while, that was caught on to some minor degree. If you walk through almost any lab, that does hardware at Microsoft, you're going to see, physical equipment, right? And you still see scopes marketed as, wow, this scope has a 7-inch screen, even though it still has a VGA connector off the back, and it's just running Android typically, right? Inside. Yeah. So it is just a PC, but and you can make the argument that, wow, this is really dumb. We really should have gone to this virtual instrument model, a long time ago. But people don't like it, right? And they find it much easier to deal with these physical knobs and dials with separate pieces of equipment, replicating the screens over and over again, even though a nice PC would do much better and be far cheaper.
Right. Yeah, it's apparent to me. And in fact, just because I picked on you earlier, I had an experience that made me feel very old when students, a new student came and joined and wanted to do this, and he wanted to extend the conductor. And the conductor app that Peter wrote just ran on tablets and other Android devices. He wanted to put it on the watch to start to do some of the stuff that Anthony had done while he was at Autodesk. And so we buy him a watch, and I don't remember which one it was. And he starts wearing it around everywhere and trying it out, and just also having a smartwatch. And then we asked him, what do you like most about the smartwatch? And he said, I asked him, do you play music on it? Yeah, kinda, use this, use that. He said, what my favorite thing is that it has the time on it, and I know I can always just look at my wrist and know what time it is. Like, oh, okay. That's right. Yeah, I said that to him. I only have to replace the battery in this every 3 years, and oh my God. Yeah.
How much do you have to pay for it?
That's right.
I feel like you push to a bit of heterogeneous spaces of the different device sets. But it'd be more interesting to push it toward more heterogeneous interaction vocabulary sets, because I feel like current examples are mostly based on the pointing and clicking paradigm. So, for example, what a device supports bending, tilting, or grasping, then the way the component that has been transmitted from there to here should be very different, right? Then it may have issues for all the users, developers, researchers, etc. Because developers should care about how to make the component interaction agnostically, and the users should adapt their mindset to the different affordances of the devices. Mm-hmm. And the researchers, some researchers are developing new interaction vocabulary, and they should care about the compatibility between the new one and the old one. Should that be another line of the tube that says bendability of a devices?
Yes. So I absolutely agree, right? And so the point, where we started Panorama was by saying, we're going to divide up the application and then intelligently send the panels to the right devices. And then a clear natural next step is, once the panel gets there, what should it do? Should it just be the same, or should it be customized to the input capability? And I'll give you 2 pointers. One is Christoph Gaius, who's last time I know how to pronounce properly, who looked at some of this for mobile devices a long time ago. And then the other is, in fairness, that was one of the key things from Anthony's project that I didn't have time to show you, so you should see the paper, where he looked at, if you have a watch and a phone working together, what are the right interactions to put on the watch, what are the right things to do on the phone, and how does the sensing capability of each complement each other? And so what I think of as the next step for Panorama, which is the toolkit, although the company is called Conductor, just to be really confusing, the next step is to say, given this huge number of interaction vocabularies and all of the great work that people do all over the world of, what is the right way to interact with a touch screen when it's a phone, what is the right way to do accelerometers on a device that has no screen, and having sort of a Rosetta Stone that helps to translate all of those things, sort of like the Google Translate, I guess, of all of this, to make the panels do the right thing when they get there. And I think the choice that we made with Panorama, which is to say, we're going to use HTML5. And so if you're using a tool like Bootstrap, which is the Twitter UI toolkit that's become incredibly popular, whatever that can do to adapt your UI to the different screen, we get that for free, right? Because you can still use Bootstrap. I'm using the right word, right? Bootstrap, yeah. Is that? Yeah. If you're using Bootstrap, it'll do the right thing when the panel gets there, but it's not enough, right? It doesn't say, you need to point at this list, but there isn't a touch screen on your watch, but there is an accelerometer. So how do you do the right thing, right? So I 100% agree. It's the right next step for this project. I wish he would stay and do a PhD, but he wants to go get a job instead.
All right, folks. Let's give another round of applause.
Thank you.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.